Namaskar, everyone. Welcome to the Saraswati Sangam Project Eminent Scholar Lecture Series. It is our honor to have Professor C.K. Raju as our eminent speaker today. Before I introduce our speaker, I want to share a little bit about the Saraswati Sangam Project and hence the blank screen you see right now. The Saraswati Sangam Project is a center of excellence dedicated to advancing and supporting research and dissemination of scientific inquiry grounded in Vedic knowledge. TISP has several threads of activities to serve its mission. We have original content we develop, which is available on TISP YouTube channel. Please search for Saraswati Sangam on YouTube. We also support others' efforts, such as Pracham documentary series on Indian contributions to the world. TISP confers awards such as the Eminent Scholar Award, research scholarships, as well as grassroots research by acharyas at Gurukuls in India. And we are currently in the process of developing a Hindu science program for high school students. We recently launched a writing competition and mentor program designed to facilitate and enable youngsters in their educational and career pursuits, aligned with and empowered by the shared roots of our ancient heritage. Today, we are honored to have Professor C.K. Raju as our eminent scholar lecture series speaker. Professor Raju holds a degree in physics and mathematics with a doctorate from ISI Kolkata. After initial teaching and research roles in mathematics and its applications to quantum field theory, Professor Raju joined C-DAC to play a key role in building the first Indian supercomputer, Param, for applications of national importance. Professor Raju has written numerous books, including Cultural Foundations of Mathematics, proposing a new philosophy of zeroism, and has compiled evidence of origin and development of calculus in India, followed by transmission to Europe in shorter books such as Is Science Western in Origin, Ending Academic Imperialism. He has developed and taught several decolonized courses on calculus, geometry, statistics, and history and philosophy of science, and has lectured on all 6 continents at very prominent places such as MIT, Australian National University, National University of Singapore, Max Planck Institutes, and even in refugee camps in Palestine and remote villages, schools in India. So we are absolutely privileged to have Professor C.K. Raju with us. We are also privileged to have conferred the 2022 TISP Eminent Scholar Award on Professor Raju in recognition of his contributions to advance ancient Vedic knowledge through the rigor of scientific inquiry and enhance the present-day awareness of the vast knowledge heritage of India. Today, Professor Raju is going to talk about Western appropriations of Indian Ganit and its contemporary consequences. So delighted to turn it over to Professor Raju.
So I want to talk about this, and I don't know how much time this will take. I'll try not to take too long, especially because it is late at night for me. Well, not exactly very late, but it's as they used to say for Capablanca, game adjourned due to lateness of the hour. All right, so let me start by telling you how I got into this. There was a project called the Project of History of Indian Science, Philosophy and Culture. That was 30 years ago. You know, there was a group of very influential people. D.P. Chattopadhyay was a minister in Indira Gandhi's cabinet, Ravinder Kumar, Daya Krishna, Rahman, Kapila Vatsyayan, G.C. Pandey, all of them are unfortunately dead. And I'm currently alive only because I was the youngest at that point of time. But what we decided was that we should tell our own stories. The West has been telling our stories for us for far too long. And so we need to tell our stories. And then I authored my book, which was Cultural Foundations of Mathematics, which was part of the PHISP series. And it was about the cultural foundations of mathematics and the transmission of calculus from India to Europe in the 16th century. So this was the 50th, and I can't cover the whole book, obviously, but I'll just cover some highlights. And so a key thing that I learned is that history is about the future, not the past. I was when I first went in, I was into science and math, and so I didn't believe history was worth anything. But then that's what I learned. So we are not doing it in order to talk about past glory. We are doing it in order to talk about what we should do in the future. So that's also my key point, that Indians not only did calculus first, but they did it differently and they did it better. So it's not a question of past glory. It's of the future. It's about technology development for the country, in fact, for the whole world. So I have a long article on that, about 10,000 words. Maybe you can take a look at it in the context of what has happened in California. They've canceled the calculus. And it's in the context of math education for children, because most people find math very difficult. And children find it very difficult, and they give it up, and so on. And that's the second part of the article. The point is, when I say we did it differently, or Indians did it differently, people don't understand it. Everywhere in the world one goes, they say, what is there to decolonize in math? You know, what is there? How can there be different ways to do math? No, it's 1 + 1. And colonial education teaches us that math is universal. And then, of course, it's all about rote learning, and it tends to make the colonized very ignorant. So they swallow the myth that math is universal, even for extraterrestrials. We send something, some value of pi or something for in some spacecraft and things like that. So when they say 1 + 1 = 2, they are really imagining the kindergarten lesson. So of course, the kindergarten lesson is pretty obvious, but that doesn't mean that that's the only way to do it. And I want you to think of this 378-page proof of 1 + 1 = 2 by Bertrand Russell. Now this is page 378, where he's actually proved it. And I constantly keep asking people, do you understand anything in this? Do you understand one line? And most people don't understand. Now, why do you believe this? And why is it so horribly complicated to prove 1 + 1 = 2? And how do you know that it is right? So 1 + 1 = 2 can be awfully complicated. But if you think this is complicated, wait till you see my next challenge. It's my Cape Town challenge, which is to prove 1 + 1 = 2 in real numbers. Please note that in formal mathematics, 1 is not something unambiguous. 1 in natural numbers or 1 in cardinals is what you saw. 1 in real numbers is quite different. Yano's axioms might apply there. They do not apply in the case of real numbers. So this is my Cape Town challenge. And it is that if you, I offered a prize of 10 lakh rupees for it in JNU. Nobody took it up. I offered it in Cape Town, where the mathematician who was there, he said, use Yano's axioms. Obviously wrong. He doesn't know 1 + 1 = 2. He was retiring. That's the case with mathematicians. Imagine what happens to others. So that is why I have proposed this as a test for public debate. So 1 + 1 = 2 is a very big thing in real numbers, because you need to know axiomatic set theory. And very few people know that. You learn naive set theory, but very few people learn axiomatic set theory and to construct real numbers and use them and so on. But that is essential for calculus as it is currently taught. Question is, what does it do? So the reason why it is so complicated, that is what I want to ask. I mean, I'm offering a prize of 10 lakh rupees for 1 + 1 = 2 in real numbers. And why am I offering that? Because it is so complicated. I don't know anybody in India who can do it, frankly. And the reason is that that is what you need to know, that formal mathematics, the mathematics that we teach, that we used to do calculus, it prohibits the empirical. So the kindergarten proof is rejected on the grounds that you can see the apples or oranges in question. And this is something stated clearly, well, not clearly, it is stated, though not so clearly, in the NCERT text. I'm sorry, it states that beware of anything that you can see. It is in the NCERT 9th standard text. Beware of what you can see. So empirical is prohibited. And the kindergarten proof of 1 + 1 = 2 is prohibited because you can see the apples and things in question. And the idea is the empirical is fallible. If you can see it, it's something wrong with it. All right, so Indian Ganit was different. And the point is that colonial math, it claims that it is superior. And so its Indian school text says it is, beware, each statement of the proof has to be established using only logic. Beware of being deceived by what you see. So if you see it, there's something wrong. That's the point that is being made. And I was in which one? I was in this one. So I don't know why. Okay, so the Indian school text says that there is no notion of proof in Indian mathematics or in any mathematics anywhere in the world except for the Greeks. Everybody did mathematics. Mayas did, the Egyptians did, Mesopotamia, Iraqis did, but there is no clear evidence that they used proof. Complete lie. And this is being stated in the school text, and all of mathematics is being fashioned on the basis of that lie. So let me tell you why it is a lie. In India, we have a clearly stated notion of proof in the Nyaya Sutra 2. So this is the statement. Pratyaksh, Anuman, Upman, Shabd. 4 words, Pramanani. So these 4 are means of proof. And these means of proof are used in mathematics. All right, they are used in Indian Ganit. And here are the examples. So for Pratyaksh, you have in Ganit 13 that how do you judge verticality? By a plumb line. That's the way a mason does it. West will say, that is some masonry, that's not mathematics. And I have the other point of view that what is being done is metaphysics, not mathematics. All right. And the fact that you're using the pratyaksh, that you, okay, measure the horizontal by means of water, doesn't mean that you're not using reason. That's a very nasty caricature and a very illiterate caricature. So, for example, Anuman is reasoning, is inference, and in goal 6, where Aryabhat will say that the earth is round. How does he know the earth is round? Did he go to space? No. He inferred it. How did he infer it? Very simple. If you are seeing if you are seeing a ship, it disappears over the horizon. If you look at a tall tree, you can't see it from far off, or a tall mountain, you can't see it from far off, and that's what Lalla says. And there are other means, analogy, upman, or shabd, which is authority, which is used in Manav Shudh Sutra. I won't go into that, but it is like citing somebody. You are using authority, somebody did it, or you are using analogy. Aryabhat will say earth is round like a kadam flower, which is a round flower. Okay. So the point is, there is a means of proof. It's a different means of proof because it accepts the empirical. And this is a key, I mean, this is a fact which is never explained in any text, and which is not never properly explained. They keep saying it's reasoning, reasoning, reasoning. Everybody used reasoning. And the fact that you use the empirical does not mean you are not using reasoning. I just give you an example. You are using reasoning with empirical facts, as is done in science. Science uses the empirical. Does it mean it does not use reasoning? It's an illiterate caricature. Sherlock Holmes says it's a capital mistake to theorize in advance of the facts. What is the deduction he does? Based on facts. That's normal reasoning. You see smoke, you infer fire. Based on facts, you see something, infer something else. But this reasoning without facts is unique to the West. Okay? So this normal reasoning has existed, but this thing is something different about reasoning without facts. And that's axiomatic mathematics, and that's what we need to understand. So I think I already explained that goal 6. So this is the difference between normal math and formal math. All over the world, people did normal math. Now the thing which is attributed to the Greeks, falsely attributed to Greeks like Euclid, no evidence, no axiomatic proof anywhere in the Euclid book, total falsehood going on for centuries. So the point is that this is normal reasoning based on facts, which is used in science, which is used in Ganita. But what you do in formal mathematics, why you need 378 pages to prove 1 plus 1 equal to 2, why nobody is able to prove 1 plus 1 equal to 2 in real numbers, is that it is reasoning without facts, reasoning minus facts. That's the critical thing that nobody points out. They keep, going tom-tomming about reason. So I think that's the critical point we need to understand, which is not explained. And then the next question is, why is the empirical prohibited in axiomatic math? And the claim that is made is that the empirical is fallible. Empirical proofs are fallible. Yes, they are fallible, accepted everywhere. In Nyayavali 304, Raju Sarpanya, you might mistake a rope for a serpent or a serpent for a rope. The classic example, everybody accepts it. Science accepts that there are experimental errors. Does that mean that you give up experiment? No. You accept experiments, you repeat them, you control the experimental error. And science accepts empirical proof, so why don't you want to accept it in mathematics? Science is still the best means of knowledge that we have. So what is this thing which is somehow better than science by not accepting empirical? So there's a superstition. It's a complete superstition that deduction is infallible. And it's on the basis of that superstition that we are teaching axiomatic mathematics. Because if you say that is the part which is not said, everybody agrees that empirical is fallible, but that unstated claim or the contrapositive that banning the empirical is going to result in infallibility. Why banning? You must be getting something better. What is that something better? It must not be fallible. That's not stated, because if you state it, it sounds absurd, it sounds silly. That is why I'm stating it. It should be stated, it should be publicly discussed. Why are you banning the empirical? And it is not done, and that is where all the problem arises. So pure deduction minus facts should be infallible. Is it? It sounds like a silly superstition, just like saying that the Pope is infallible. Anybody who says infallibility is coming from there. Nobody else claims infallibility. Everybody is fallible. I make mistakes all the time. Everybody is fallible. So again, let's ask the question, why prohibit empirical? And the fact is that it did not suit science. It suited the church. I should have a reference here somewhere. Anyway, the reason is that this was done by the church in church rational theology. They wanted reasoning, but they did not want facts, because church dogmas are all contrary to facts. And take virgin birth, for example. So, church prohibited facts. Church benefited by prohibiting facts in reasoning. And church accepted reasoning in the 13th century during the Crusades, at the time when Euclid book also came to the West, to Europe. And that is when the two things got mixed up. So it has nothing to do with Euclid. It has something to do with the church. And there are no facts are not banned in the Euclid book. They were deprecated but not banned. So church invented formal axiomatic reasoning minus fact for the church theology of reason, crusading theology of reason. Most people don't know it. And because of the overpowering influence of the church on the Western mind, it came into it. So they have a full article on it. If you like, you can take a look at it. It is an article on Medium available. take a look. It will be published eventually in some book, Church Origins of Axiomatic Math. It's about 8 to 10,000 words, 33-minute read. Please do take a look at it. And during the Crusades, the church set up the Christian theology of reason to compete with the Islamic theology of reason, Akli Kalam. Because they were fighting the Crusades for war against Muslims, and they couldn't win the war, so they had to get into debates. And they could not debate with the Muslims because they could not say Bible says this, the Bible says that, because the Muslims did not accept it. So Muslims accepted reasoning, and therefore the church wanted reasoning, but it could not accept reasoning with facts, and so therefore it accepted axiomatic reasoning. Okay, reason plus facts leads to Ganit, leads to science, but that is what was wrong with it for the church. And they said superior, it's superior, everything they do is superior. That's the basis of racism, that's the basis of the colonial claim of superiority, just claiming that things are superior and building a false history on that. So let me give you a concrete example that I'm not just talking in the air. Summa Theologica. Aquinas was the critical theologian in the church theology of reason. So I'm giving you a reference to Summa Theologica. All right, please take a look. What is he talking about? He is talking about angels, whether several angels can be in the same time in one place. Now I ask you, what are the facts about angels? Obviously, there are no facts about angels. There are no angels. How do we know about angels? So he's going to reason about it. All right, and people will say, church propaganda will say, nobody did this. That is why I'm showing you the original source, Summa Theologica. This is, you can find in newadvent.org or anywhere else you like, Summa Theologica. And this is what Aquinas does. So he wants to claim that many angels can fit on a pin. That is what he is dreaming now. You want to reason about it, prove it, that's Aquinas' theorem. So this proof cannot begin with facts. Such a proof must begin with non-facts, it must begin with axioms, it must begin with assumptions. Because that's what an axiom is. It's not a truth, it is an assumption. And that 9th standard text would also say axioms and postulates are today treated the same, they're one and the same. So Aquinas assumed, and he assumed whatever he wanted. That's the whole point of axiomatic mathematics. You assume what you want to prove what you want. And this was the key concern. They wanted to prove things, and that also became a key concern of axiomatic math. For applications, you want to calculate, you don't want to prove things. So the question again is, what is better, normal math or formal math? And axiomatic maths, the mathematical proofs are inferior since highly fallible. So I have a whole article on it again, Decolonizing Mathematics. This is an address that I gave at Durban, and it is there in their journal. So it's available free of charge. Alternation is the journal. Please take a look at it. So I'm saying it is highly fallible, not only not infallible, it is highly fallible. Why? Hey, I was a teacher of mathematics. Students used to keep giving wrong proofs. If it is infallible, then every proof they give should be right. How can it be? It is completely, not acceptable to say that something is infallible. They make mistakes all the way. If it's infallible, they should never make mistakes. Every time they used to make mistake, they flunk. The difficulty, they get 0. And if you say students, they are just learning. What about authorities? So many wrong proofs are published of the Riemann hypothesis, and so on. And I showed you that 1 + 1 = 2 proof. Do you think there is no mistake in it? Not even a typo? 378 pages of what you don't understand, and you are sure there is no typo. How? Just blind belief in authority of Russell. There is no other means of knowing, because unless you go through it and check it 100 times inductively, you don't know. So you have 2 ways of doing it: either rely on authority blindly, which is any form of superstition is reliance on authority, or inductively check the proof 10 times. See, for my PhD thesis, I had to do a 110-page calculation. Those days, you used to do calculations by hand. And I had to repeat it because I didn't know 110 pages calculation. You may go wrong somewhere, so I had to check it. It took me months to check the calculation. So deductive proof can only be checked inductively, the validity of deductive proof. And if it is not valid, it's fallible. How do you say it's infallible? But worse than that, they are more fallible because, they are certainly more fallible than proofs based on authority or inductive proofs. So they are more fallible than empirical proofs. but they are also more frequently fallible. So chess is my example. Chess is a matter of pure deduction. Even Hardy will admit that chess is mathematics. But every human makes a mistake every time, and almost every time. Let me put it like this. Almost every human makes a mistake almost every time, therefore loses to a computer world champion. Poor fellow will keep losing to a computer because he makes a mistake. You can't lose a game of chess unless you make a mistake. So since it happens so often with the most authoritative individuals, therefore it is more frequently fallible. So why prohibit empirical proofs in math? So anyway, this is based on superiority, was based on false histories in the 5th century. The church wanted to establish superiority. So this is in an article. I just written some models. It is not just one thing, it's going on for 1500 years. So there was an Orosian model in the 5th century, then there was a Byzantine model where they took all the work that was being done in Baghdad and appropriated it and then put in Greek names. And there was a crusading model when Arab texts were wholesale attributed to Greeks because Greeks were the friends of Christians. Then there was the inquisitional model, people like Copernicus, they took things from Ibn Shatir and then he just translated it and he declared a great revolutionary. And then there was the Christian discovery model, which I'll be talking about, because they could not use any of these other models in that case, where they took stuff from India, for example, and from other places, and they said, we discovered it. Why? Because we are Christians. Christians have a right to the land they see. That's how all land holdings in America are decided. The original inhabitants are all dead. They were killed. All the Americas and Australia, the original inhabitants were killed, and it was done on this basis. That is the legal basis. It is still part of the US Supreme Court judgment. And I have an article on it, which you can see if you like. So false history has been the basis of that claim of superiority. And that claim was picked up, false history was picked up by racist and colonial historians. So they said, the West, whites are superior. They said, West is superior. And that's the whole problem that the colonized and blacks have got. That these guys just said they're superior. It's like saying this mathematics is superior. How is it superior? Come on, let's see. They will never discuss it. So the main lesson of colonial church education is this: the white West are superior, imitate it. West is superior. So it shifted from color prejudice to civilizational prejudice. I have a long article on that, from which I just showed you that Euclid must fall. And the point is, well, our education minister boasted we have not changed a single comma or full stop, because our job is to imitate. If we change a comma, maybe something will change. So that's so they said that Greeks did something superior. No, Euclid did something superior, and this math was therefore globalized by colonial education, because that's when Euclid came in. Otherwise it didn't exist in Indian thinking, or in any other thinking for that matter, not in African thinking. Or so the point is, all I'm saying is, you can't believe all these nonsense myths. You can't say we don't do it. They frighten you with mathematics because you don't know mathematics. And then they say this expert knows, and the expert is under their control. So don't believe the experts. Let's have a public debate. What is this deciding things in secret? And everybody is dodging public debate for the last 6 years, 7 years. Only one debate took place in South Africa, and you saw how the mathematician muffed it. He said piano diagrams for real numbers. So the point is, we don't want that. We don't want manipulative, secretive refereeing where you submit somewhere. Why is it so secretive? What is secrecy? What is the value of secrecy for science? There's no value for the truth. There's value only if you want to manipulate. So why is axiomatic math or Western ethnomath superior to Ganit or any normal math? I think we need to have a public debate on that. We are not able to do it. I'm willing to do it while I'm alive. And if you know anybody who wants to do it, who is willing to do it, I'll be happy to debate. As I said, while I'm alive. So it affects the current, all this false history, the church history of Euclid is essential to math in the Indian school text. So there you have chapter 5, Euclid's geometry and so on. And then they will inject a metaphysics of infinity which actually relates to political church dogmas of infinity. I will not go into that. I'll just give one example. If you do calculus, you must use real numbers according to current college text, which means if you're using calculus for science, the time must you write down differential equations. The time that comes there, you must use real numbers in order to write down the differential equations. That forces time to be superlinear like the real line. And that makes science pro-Christian, contra-Hindu, contra-Islam, and so on, without reference to facts. See, these things are wrong, it is one thing, but without reference to facts. And that is the problem, that you're doing it without reference to facts. Just because somebody said this metaphysics must be there, you have to do it. So that is very problematic. And there are other reasons for you to worry, because makes it difficult for your children. There forces epistemic dependence. Even for 1 + 1 = 2, what do you know? Oh, I don't know. Let's ask an expert. So this sort of thing is very problematic. And because math is a compulsory subject, it is not even secular. Unlike Ganita, there is a problem. In fact, the word mathematics, as you know, comes from mathesis, which relates to the soul. Plato related it to the soul. Proclus related it to the soul, and that soul was similar to the Hindu notion of Atman, or the Egyptian or the pagan notion of soul, which was cursed and changed by the 6th century church. I won't go into that. And I just want to say it is not secular. It is violently anti-secular. Just people don't understand it because they don't understand real numbers. They don't understand what was that notion of soul and so on. So anyway, it results in the difficulty of teaching calculus. We can talk of that. The California math framework cancels the calculus, and you need to have that calculus because knowledgeable manpower is needed for technological development. And so this philosophy is globalized, it is entrenched, and then false history too, that this is superior, and it's a very Herculean task to clean this 1600 years of filth in history. It's 50 times bigger than Hercules' task, because he had to clean the Argent stables, but that was only for 30 years. This has been accumulating for 1600 years. So I'm sorry that I took such a long background. So about how the West transmogrified the calculus. Let me come to the talk today, that the calculus originated in India, but the story does not end there. It was stolen by Europeans who failed to fully understand it. And then that results in contemporary consequences. What Europeans did to cover up for their lack, they understood that they did not understand it, was that they added metaphysics, which just makes calculus difficult without adding an iota to its practical or epistemic value. So therefore, we need to change the current teaching of calculus, indeed all math, in the interests of your children, in the interests of future technology. All right. So I'm in the interest of secularism, since just metaphysics contains a religious bias. So let me come now to the question, who invented calculus? So NCERT text, of course, attributes calculus to Newton. There you are. And you see what they say. It's a chapter on limits and derivatives. It says we do not actually define derivative, because you can't define it. You need real numbers, you need all sorts of things. Then we give a naive definition of limits. So you give a naive definition of limits, and what happens is that students don't understand anything. Or the most important thing there is the picture of Newton. Newton invented. So they are essential to define the derivative, but it does not define the derivative, does not define the real numbers needed for limits. Therefore, it does not define limits, and students stay totally confused. So here is my calculus pre-test. So take a look at this, and you see what happens. This is the latest one that I tried. Let's take a simple thing. People don't know what are limits. They're totally confused. If you ask them to define, they don't know. And if I say I've got something like square root of 2, and I'm taking these numbers, do they have a limit? And then I say, if I take 1 + 2 + 3 + 4, what is the limit? What is the sum, infinite sum? Can it be negative Ramanujan sum of 1 + 2 + 3 + 4 is -1/12? How can that be possible? So it is beyond their understanding. And then if you take simple series like 1 - 1 + 1 - 1, then what is the sum? Now I have defined a sum for it, and that sum will turn out to be half, never assume that value. 0, 1, 0, 1, and so on. So if you have a lamp, if you're doing it physically, it will be half on, half off, therefore it will be half. It's a complicated theory, won't get into that. But then I ask them to define a derivative. They can't define the derivative of function. If I give them natural numbers and ask them what is the derivative of fx equal to x squared, they don't know how to do the domain changes. They only know the formula fx x squared, then derivative must be twice x. And then I ask them what is the derivative. They don't know is it's tangent to a curve. What is a tangent? They don't teach the tangent. It just touches the curve. So I give this example of x sine x, and then I say draw the tangent here. To draw the tangent here, it's going to intersect the curve at infinite number of points. And they don't know what to say. So it just touches the curve. I mean, it is complete nonsense. It has nothing to do with it's a purely local thing. So they don't teach the tangent. And the whole idea of doing limits is that this sort of geometric intuition does not work. And then I ask, of course, for the integral of a function and so on. They don't know how to do it. They have formulae. So if you give them a simple thing like this, dx by x, then they will say, okay, it is log x. Then what are the limits? -2, -1. So they'll say log -2, minus log -1. So what is log -2? And it goes on like that. And then you only teach integrals of elementary functions. So if I give something complicated, then elliptic integral, they cannot do it. They never learned it. So it is as bad as that. They are not able to get even 0 because they don't know what they don't know. At least if they know we don't understand it, they can say we don't understand it, they will get 0, but they think they know. That's the kind of nonsense that results in the teaching of the calculus. It happens everywhere. It's not just in India, it happens everywhere. So now the next question I want to come to is who in India invented the calculus? So I'm saying that Aryabhat first gave 24 sign values. Now this is actually a single verse. So the verse goes like this, and it's a bit difficult to translate. Maki, baki, faki, daki, it goes on like that. And the point is, this is not Sanskrit. It is written in Devanagari. There is only one Sanskrit word, and that is Kalardhaja. All right. And the translation, those are rest of them are numbers. So there is a translation, and this is the translation, which is, well, I won't go into it in too much detail. I just want to say it uses a numerical notation, which is a novel notation used by Aryabhat. It will take me about 15 minutes to explain it, so I'm not going to go into it unless you ask me questions about that. The Kalardhaja, Ardhaja is half, Ardha is half, Ja is half chord, which is sign. So it is, word sign comes from there. From Ja it went to Jiva, Jiva to Jiba in Arabic. And Jiba in Arabic, the Toledo translators, who were Mozarabs and Jews, they could not understand because the Nukta system was not prevalent at that time. So it was just a consonantal skeleton Ja, Ba, and therefore they read it as J, which is pocket, the easy word for them to understand. And therefore it became sinus, which is a fold, and from there it became sign. And we teach that nonsense. So it completely loses track of what we had. So Kala is the first sexagesimal minute, and Vikala is the second, and Tatpara is the third. So Aryabhat had accuracy to the first sexagesimal minute, which is about 5 decimal places. For example, his value of pi, which interestingly is given like this in a verse. And this verse is interesting. We'll come back to that because it's a prolix statement. And the prolix statement shows its origin because when people repeat that prolix statement when they have no need to, he did it for the sake of meter in verse. So this is accurate to 5 decimal places. And Al-Khwarizmi repeats it and Simon 7 repeats it. So now the question is, what about the Kerala school? I'm talking about Aryabhat, everybody talks of Kerala school. So the common incorrect belief is that calculus was invented by the Kerala school. And I believe this when I started off in 1997, when I started research on that. And my project, which I submitted to the Indian National Science Academy, was on Madhav and the origin of calculus. So I was looking at Madhav of Sangam Gram, and that is what I was thinking, because that is where I started, the belief that Kerala school did it. And when my first major paper was this article in the Philosophy, East and West, which was presented to the International Congress of Philosophers. It was about alternative epistemology of the calculus in the Yukti Bhasha. So it was again part of the work of the Kerala school. So I was till that time assuming that this is correct. And this is how the British learned about it, because they first learned of the Indian calculus through an 1832 article of Charles Wish, and which British lay public. The Jesuits and so on and Newton knew about it much earlier. So Madhav of Sangam Gram, he did definitely improved 24 sign values of Aryabhat. So he gave a much longer shlok, as you can see, Shreshtam Nam, Varishtanam, and so on. What does all this mean? How is this a sign table? He made it precise to the third sexagesimal minute. So actually these words are expressions of the minutes, seconds, and thirds. Reverse sexagesimal Katapayadi system. Difficult to explain all of it. If somebody wants, you can look it up also in my book. Point is that Katapayadi system is just a simple system, Kata, Pa, Ya, Adi. Okay, that's just the alphabet. It's based on the alphabet. So Kata, Pa, Ya, etc. So you just have each letter represents a number, it represents a digit. So that's a simple system. So a popular system, because you could make verses easily with it. But point is, Madhav Sangam Gram improved the accuracy to about 9 to 10 decimal places. And this is his sign table. It is his improved version of Aryabhat's sign table. Same 24 values, but done more accurately, done to the thirds, not the minutes as Aryabhat did. And this was some 900 years later. So, question is, can one say Kerala school invented calculus, not Aryabhat? And why not Vateshwar? Because it didn't just happen directly. There were intermediate developments. So Vateshwar did it to the seconds, and he did 96 values, the 10th century. So why not he? What was the critical qualitative difference? There's a quantitative difference, no doubt. Right? He has better accuracy. And there's also a qualitative difference. The Kerala school had infinite series, which is not found in Aryabhat. So Nilkant, he was the first to sum the infinite geometric series in Ganit 7. He's writing a commentary on Aryabhat. He's a disciple of Aryabhat. He is the key mathematician of the Kerala school, about whom we know something because we have a whole book. So he was the first to sum this infinite series. And his sum is the same as what we have, but that formula is first stated in Nilkant's Aryabhatiya Bhashya. It's just the usual formula, except that you have a common divisor instead of a common multiplier. But he summed the infinite series, the Anantya series. I'm sorry, did I show you that or not? It is Anantaya, right? It's an infinite series. All right, it's not a finite series. Because finite series are very old. Finite series, you will geometric series, you'll find in Yajurved 17.28, it's very old. You'll find it in the Eye of Horus fraction. So this is very famous fraction in Egypt. So this is again a finite geometric series. It's a beautifully depicted geometric series. And they make all sorts of Hollywood films about it, you know, make the eye a literal eye without understanding the symbolism. What can one do? So the point is, yes, there is some infinite series. But what is essential about infinite series to the practical application of calculus? I asked myself that question when I started teaching calculus based on the Indian method. and I couldn't give any answer. The Newton did not know how to sum infinite series. Leibniz did not know how to sum infinite series. Descartes did not know how to sum. He said it's beyond the capacity of the human mind. Galileo did not know how to sum it. So he left it to his student Cavalieri. The computer cannot sum infinite series. Newton obtained all the practical results for his physics without summing infinite series. All practical applications today, you want to send a spacecraft to the moon, you are going to do it on the computer. You can do it without summing infinite series. So no one knows how to sum the S-matrix expansion of quantum field theory. They don't even know how to sum even one term is a problem. But all experimental consequences of quantum field theory come from there, all that 7 decimal place precision that they talk about. So my calculus course stressed 4 key aspects of Indian calculus. First is that the derivative is always a finite difference. It's very important. Khandaja, including backward and forward differences, which were introduced by Brahmagupta in the 7th century. It's taking a long time. Yeah, so he talks of the past difference and forward difference and uses this for quadratic interpolation. He is deriving something which is called Stirling's formula today, because these Westerners always put their name on everything. Who discovered the source of the Nile? It's a Westerner. Who discovered the top of Everest? Some Western name. They put their names on everything. Oh my, I think I seem to have been taking a lot of time. Huh? I need to go a little faster. I'm sorry. Okay. So this is going too slow. Integral is obtained only by numerically solving a differential equation. A differential equation is a process of integration. And the Euler method, so-called Euler method, was invented by Aryabhat. And he did it in a very simple way. It's a simple rule of 3. The sine function changes by this amount in this much space. So how much will it change by? So simple linear interpolation, extrapolation. And Aryabhat's sine table, by the way, if you go back to it, it has only sign differences, not sign values. Because he realized that only sign differences are needed for extrapolation, interpolation. Not derivatives, as Marx said, he could not understand what derivatives meant. He thought it was mystical. So the non-Archimedean arithmetic of Brahmagupta is the third part. Avyakt Ganit. This is critical because real numbers are Archimedean. This is the part that the West did not understand. And the fourth part is the West had a belief in exactitude because they had a religious thing about mathematics being eternal truth. And that is where Shunyavad comes into the philosophy of inexactitude. So these two things can be used to sum an infinite series. How if you have, say, geometric series. So now this formula is pretty clear. You just multiply 1 minus x at the other side and you will get 1 minus x raised to n plus 1. But if you have non-Archimedean arithmetic, it allows infinities and infinitesimals. And the non-Archimedean arithmetic is the arithmetic of polynomials, which Brahmagupta invented. Avyakt Ganit. This the West never understood. And they understand it now in the terms of non-standard analysis, but not in terms of doing calculus right like this ab initio. So it's quite clear that if n is infinite, then if x is small, x raised to n plus 1 is infinitesimal. Again, so this is something which requires a lot of explanation. So these aspects of calculus all antedate the Kerala school. And so the conclusion is that the credit for originating calculus goes to Aryabhat, Euler method, or to Aryabhat and Brahmagupta. Not to the Kerala school, it is incorrect. Though of course the Kerala school contributed to its development and contributed to the infinite series. Infinite series are just an easily recognizable form. You cannot use it to teach calculus in class. Because that's when I started teaching, I realized you just can't use Kerala school. Okay, so let me come to the next question. Why Europeans stole the calculus? Basically to solve the navigational problem. I seem to have taken a lot of time. I'm sorry. I have only covered about 50% of my stuff. Maybe please let me have your little patience. Sorry. So navigational problem was a major problem, and European governments announced huge prizes for its solution, the last being the British Longitude prize by an act of parliament in 1711-12. So there were three problems: latitude, longitude, loxodrums. So they kept giving these terrible exaggerations about Greek prowess in mathematics. The Greeks didn't know basic arithmetic properly. Therefore, they didn't have, they were very backward. Therefore, they had a bad calendar and they didn't have efficient arithmetic, obviously. Hence, Europeans repeatedly imported Indian arithmetic from 10th to 16th century. And the non-textual evidence is very solid. They didn't know fractions. Therefore, they had a defective calendar. Fractions were introduced in the Jesuit cylinder in the syllabus in 1572 by Clavius by importing from India. Point is that solar and lunar cycles are not an integer number of days. So you need to have good knowledge of fractions. And an accurate calendar or accurate equinox, which is needed for navigation to determine latitude at sea from observation of solar altitude at noon. So that is, well, do I need to clarify this? You just observe the solar altitude, and if you know the declination based on the equinox, and you can calculate the declination if you know the correct date of equinox, based on that, you can calculate your latitude at daytime. All right. The Mercator map needed trigonometric values, because the problem was that the Europeans did geometry with straight lines and they navigated with charts, maps, the two-dimensional maps, and they do not solve. But on the curved surface of the earth, if you go in one direction on the compass, they said you have to move in a straight line, but you don't move in a straight line, you move in a spherical helix or a loxodrome. So if you are going in one direction, constant course angle, you are going to spiral towards the poles. And this was a big problem for them, because they said if you move in one direction, then you should move in a straight line. And therefore the Mercator chart was invented. It has various kinds of biases, but they are not colonial biases. They are just because they wanted, they could not navigate any other way. So Greenland is so big and Africa is relatively small. And this is not a colonial bias. It was because of navigation. This is just a usual map of the world. It's taking too long to load. You know what I'm talking about. So table of seconds was needed for the Mercator projection. So this is the way to calculate the Mercator projection maps, loxodromes, to straight lines. And for that you need the value of, if you want to carry out this integral, which was done manually, numerically, you need a table of seconds. And so that is why every navigational theorist had a table of seconds. Seven, for example, will have a table of seconds at the end. So that is why you have this. And well, I've already said that you can determine it, latitude, so you can have some empirical fit to the declination. If you observe the solar altitude at noon, you know the number of days since equinox, but you need to know the correct date of the equinox. So missing in the official Christian calendar, which was the Julian calendar at that time, and the Gregorian reform tried to do it, but they still didn't know fractions. Therefore, they used the primitive technique of leap years. It is right there in front of your eyes. Big mathematicians from Greek times, they didn't know even fractions. That is why the Julian calendar used leap years. That is why Gregorian calendar uses leap years. It's a very primitive technique. It does not get the equinox on the same day of the calendar. So you get it right only on a 1,000-year average. Then if you want to determine longitude, then you can do it in various ways. One, you see, you have to solve the nautical triangle. What the Europeans did was they heaved the log. So they threw out a log and they counted its speed by measuring the number of knots in a rope tied to the log. That's why you have a log book, and that is why you have the concept of knots, speed and knots. But you don't have to do that. Indians didn't do it that way. I mean, they did it. This was one of the techniques, but they said measuring distance is very unreliable. Even on land, forget heaving the log. And so they looked at other techniques. But if you want to use other techniques, you need to know the size of the earth. I can calculate from a difference of longitude, from a difference of latitude. But I need to convert that to distance. I need to know the size of the earth. which Europeans didn't know because they were backward in mathematics. And so their date reckoning was no good. And mind you, texts like Bhaskar, I'll just give you the translation. Forget about the text. The point is that if you obtain the distance by calculating something like using the Pythagorean theorem, this is not right, because the Pythagorean theorem does not apply to the curved surface of the earth. That's what they are saying. This is the 7th century, before Euclid was known, before non-Euclidean geometry was known. But they put their name on everything. So the extent of false history is really amazing. All right. So it's a coarse measure of distance and so on. Now the size of the earth can be calculated very easily. My students do it. All right. Every Indian text had the size of the earth, but they did it in Jojan. How do we know it is accurate? We don't know what a Jojan was. The accuracy of the method is checked by Al-Biruni's method. Al-Biruni used it to check Khalifa al-Mamun's estimate. So it's a very simple method. What is it? You measure the height of a hill. You know how to use elementary trigonometry for that. Then you climb the hill and measure the angle of dip. And once on the angle of dip, you have this equation, you solve this equation, r by r plus h equal to cos theta, you will get the value. If you want the explicit solution, it is given here. It's a very simple thing to do. What does it require? What it requires is that, what Al-Biruni did it like that. He got an accurate figure. How do we know? Because Arabic mil and English mile are very well connected. And so we know his figure was accurate to within 1%. Newton was off by 40% first estimate, then 25%. Columbus was off by 40%. So the critical piece of apparatus that is required is an accurate measure of angle. An accurate measure of angle you will find in the Rik Vedant Jyotish, which is Bhansha. All right, so this is about 1/10 of a degree. Now it is, well, I don't have time, so it's taking too long to go. I'll skip the translation. The point is the instrument, critical point is the instrument Kamal, Rapalagai, which I found, which is a very simple sort of an instrument, which just consists of two pieces. Where is it? So I did it, but it's got all mixed up. I had two directories with the same name. So it's a simple piece of instrument, which consists of, important thing is two scales are being used. Each one of them is a harmonic scale. These are not linear scales. Look at the knots. They are not linearly distributed. Vasco da Gama didn't understand this. So you have a pair of harmonic scales and you use the so-called Vernier principle, two-scale principle. And the Kamal that I found had an accuracy of 10 degrees. Sorry, not 10 degrees, 10 minutes. And it had an accuracy of 11 miles at the lower end, because you use both the things together and you get an accuracy of 10 minutes, right? So that's about 1/6 of a degree. European longitude problem, as you know, the Bible says the earth is flat. Behold, a tree in the midst of the earth, and it was visible from the ends of all earth, which is exactly the counter argument that Lalla gives, why the earth is round. Because it's round, you can't see from the ends of the earth. And so they didn't, therefore, as you know, Columbus underestimated the size of the earth by 40%, better to get funding. And so the size of the earth remained unknown to Europeans until the late 17th century, but nobody believed Picard's measurement because their life depended on it. So anyway, let us, this was strong motive. Why am I going into so much details? Because the standard of evidence for the theft of calculus is that theft is a criminal offense. So I used a criminal standard of evidence as the standard of evidence used in criminal law. Motive, opportunity, circumstantial evidence, and documentary evidence. So navigation was a very strong motive because all sources of wealth that Europe had at that time, or dreams of wealth they had, were based on overseas piracy, trade, and for that they needed precise trigonometric values, and those precise trigonometric values were obtained from the Indian calculus, which was acceptable to them, which was accessible to them. Why was it? They had ample opportunity because the first Roman Catholic mission was started in Kochi in 1501 and turned into a school for the local Syrian Christians. And then the Jesuits took it over and set up a college there. And they had a common patron in the ruler of Kochi. Missionaries naturally learned the local language. They had their friends among the local Syrian Christians, and they translated a mass of Indian texts in Toledo. And I hope you know the story of Toledo, that during the during the Crusades, a huge Arabic library at Toledo came under Christian control, and they were mass translated. And since the church policy was to burn heretical books, consistent policy, how could they take it from the religious enemy? So they said it's all done by the Greeks. A silly story, and no evidence for any of those Greeks. And that story is persisting till today, and Western scholars are hell-bent on defending it, because their whole sense of superiority depends on these silly stories. So you have to explore them, ask for the evidence. Where is the evidence for Euclid? I offered a prize so long back. Nobody comes up with the evidence. They'll come up with stories, they'll abuse you, they'll make personal attacks, they'll do everything except talk of the evidence. And the ones who are honest will accept there is no evidence for Euclid. Euclid didn't exist. They've been talking nonsense all these days. And the point is, it's not just the church. Racist and colonial historians took it up and they followed. I think I already gave you that and gave you the reference to this Euclid Must Fall, part 1. And the different model was used to steal the calculus. This was the crusading model. And this model that was used is called the doctrine of Christian discovery. So if you have doubts about whether it is part of US law, very much part of US law, this is the case that I've cited, and you can check it out. It is very much part of US law. I'm not just talking through my hat. I don't have a hat. Okay, so the Jesuits in Kochi had ample opportunity to translate and obtain Indian texts. Then there is circumstantial. The Jesuit general Clavius timetable is an interpolated version of Madhav's. It's also the same, exactly the same accuracy. And his contemporary Julius Caliger, for example, he uses what you call Julian days today. The scientific way of measuring numbers which NASA uses is the Indian Ahargan. Tycho Brahe was the astronomer to the Holy Roman Empire. He had a model which is identical to Neil Planck. How does it happen that all these top functionaries get in? That's where the text will go. And in fact, he kept his observations, heretical imports, secret even from his assistant Kepler, whom perhaps murdered him for them. Anyway, I don't want to get into that. So the circumstance, it goes on like that. Stirling's formula, Euler's thing, Fermat's challenge problem, which remain unsolved. So maybe I can just quickly tell you about it. It's a simple challenge problem which Fermat gave in 1657. Nx squared plus 1 equal to y squared. The solutions x and y for n equal to 61. No European mathematician was able to solve it. Till Euler did it because he had access to the same sources that Fermat had. Solution was very big numbers. And it is explicitly stated, it's a solved example in Bhaskar, Bij Ganit. All right. There's no question of independent discovery because the numbers are too large. Nobody was able to get it. Documentary evidence. Here is the original handwritten letter that I've got from Matteo Ricci, who was Clavius' student. It's also there in Documenta Indica, but you can't trust it, whether the translation is right. So here you talk of a honorable Muro honorado, or an intelligent Brahman. And he's talking about Indian ways of measuring time. Okay, I must move on. I think I can't dwell on all these details. The critical issue is the epistemic test. That the first international article to state all this was my Hawaii paper sent in 1999. And there I talked about motivation, opportunity, documentary evidence, and circumstantial evidence, and so on. So, the point is it attracted thieves. They said that if it is so easy to steal calculus for so many centuries, then Indians must be really either very trusting or you can steal knowledge from them easily. And so the whole transmission thesis was itself stolen. So the mistake I made was to advertise my postdoc position. So for my project. And then the thieves caught on to me and then they played me. George Givergis Joseph and Dennis Almeida. They contacted me and I was trusting and I gave them my unpublished papers. And Joseph organized a conference in Trivandrum to which I sent this paper. I could not attend it because this Hawaii conference came at the same time. But these chaps, point I'm making is they're very brazen. So here is a news article from 2004 where this guy was indicted for plagiarism. But he even apologized. But then he immediately stole my paper near verbatim in 2007. So this is the retraction by the Hindustan Times. That the news item they had given that these British scholars did it is wrong. So the point is that at this stage, I'm really sorry, I'm getting way beyond my time. That's the advantage, I think, of an award lecture. I can sort of stretch the time. So they got a lot of support from Indian journalists. Subhash Kak wrote about it and so on. They contacted Kak. And therefore, I even had an appendix on this in the Cultural Foundations on transmission of the transmission thesis. So therefore, I used the epistemic test. I said that you can't, you give any standard of evidence, the people are just going to ignore it. They're completely shameless, completely shameless. And so I started pointing out the errors. See, they confounded solar altitude and declination. Declination in the north-south movement, altitude is like this. They confounded the two 3 times. So I said that, this, they said solar declination can be measured at sea. So this is contrary to the whole central idea that Europe needed a good calendar. And therefore the Gregorian reform was done to determine latitude. Then they made this foolish statement about floating point numbers. See, they said that Kerala mathematicians used floating point numbers to understand the notion of infinitesimal and to derive infinite series. I mean, it is complete nonsense. It's complete nonsense. And why did they do that? Because I mentioned floating point numbers in my Hawaii paper. Why did I do that? Because I'm making a theoretical point about division by 0. Floating points are a 1988 IEEE standard. And this statement was copied from this paper. So as you see, I had given a proper program and so on, and I'm saying what happens with floating point numbers, that associative law fails for addition. I'm making a philosophical point. It's a philosophical conference, right? And then it's a IEEE standard, and I was teaching C programming at that time. So I gave this program about division by 0 and so on, which is part of that Hawaii paper, all these programs. So I said, this is the IEEE standard. What do you do by 0 by 0? So Java will say something and so on and so forth. So that's what I was talking about. What is the IEEE specification for this case? So they did not understand it and they copied it. And so therefore, I'm saying that this epistemic test is to be applied. It's like students who copy, who cheat in an exam and who do not understand what they copy. The test can also be applied to Einstein, who plagiarized some Poincaré, and to Michael Atiyah, who plagiarized my correction at about almost the same time as Joseph. I don't know why these plagiarists come in bunches like mosquitoes. So it applies also to Newton and Leibniz. They neither knew how to sum the infinite series. Newton called Leibniz the second discoverer because he asked for help. The series named after him, but he didn't know how to sum it. And Newton knew that the series was floating around in Europe from before Leibniz. That is why I called him that. Berkeley made fun of Newton's silly and meaningless fluxions. What are these fluxions? You ever hear of them? Complete nonsense. You read what I have written, I mean, read the debate which went on at that time. So I won't get into that. There is a whole article on that. It's on Marx and Mathematics Epistemic Test, because Marx didn't understand calculus. And it was not just his fault. It was not his fault, it was a fault no European understood it before real numbers. So that is what I'm saying, that infinite series is not critical for practical applications. So therefore, Newton could still derive practical applications from that. So real numbers, the invention of real numbers is an admission by the West of lack of understanding of calculus. And lack of understanding is clinching proof that Newton and Leibniz did not invent the calculus, except in the sense of Christian discovery. So it is 15 years since I wrote that one. Now, second edition is due. And then I conducted formal courses on calculus without limits, with 8 groups in 5 universities in 3 countries. So these are some of them. So this is the Central University of Tibetan Studies, Ambedkar University, Delhi. Very happy social science students to learn about it. This is in Iran, general group. And this is the one in SGT University. The 4 groups in University Science, Malaysia, included a group on postgraduate group of mathematics. 36 registered, 18 dropped out after the pre-test, which they could not do sitting in the lab with access to computers. Then Raju Ganita, which, oh my, I didn't put the video is here. I'll give you the link to the video if you like. It is part of my set of videos. I'll give you the link. But teaching experiments are performed. They are performed in Nasik with school children and with teachers. They're quite difficult to perform these experiments, you know, in Gundulupet and Indore and so on. So lots of these teaching experiments are performed, and textbook has been written, which is available in class 9. It's very difficult to do that because education is very tightly controlled. Probability and statistics. So as you have been telling you, maybe you can read it in the Wall Street Journal, that California has cancelled the calculus, cancelled math class. Probability and statistics originated in India. So here is the Akshasukta of the Rig Veda, and says so much say Maujab Tasyam Aksho. These dice have this pleasure like the som in these dice. You find it in the Mahabharata, where there is sampling theory being used to count the number of fruits in a tree. And you find these details in these articles on probability in ancient India and probability for the Springer Encyclopedia. And there is a very interesting question about logic. I won't go into that, it's too difficult to explain right now. So the point is that to do data science and statistics, which is the very critical technology today, you need to do it. You need to know calculus. If you want to drop calculus and then do statistics, it is very dangerous, because when a machine makes a decision, they make a wrong decision, a lot of people can die. So that's my conclusion. I think I will just quickly summarize. Math is not universal. Formal axiomatic mathematics is a crusading church construct falsely attributed to Euclid. Formal math differs from normal math. It adds a religiously biased metaphysics of nil practical or epistemic value, just claims superiority, whites are superior to blacks, that sort of claim. Completely irrelevant and completely without any basis. So calculus originated with Aryabhat, not with the Kerala school. And it did so because accurate trigonometric values were needed for agriculture and navigation, which were 2 key sources of wealth in India. Agriculture needs a good calendar in India, which is because calendar, because monsoon-driven agriculture. It developed over the next 1,000 years. Kerala school did many things, added, gave infinite series and gave accuracy to the thirds, but infinite series is not critical to the teaching of calculus. recognizable as calculus, not relevant to teaching. So calculus was stolen by Kochi-based Jesuits in the 16th century for solution to the European navigational problem from 16th to 18th century to determine the three L's, latitude, longitude, loxodromes, all of which required accurate trigonometric values, and European sources of wealth all depended on accurate navigation. The Western and colonized respond, they are hell-bent on defending that plagiarism. The major universities like Princeton University, Oxford University, Cambridge University. So, because their whole claim of superiority is based on that. I mean, it is like asking them to Americans to return the land in America to the original inhabitants. They're not going to do it. Right? There is no reparation of that sort possible. The black slaves whose labor created the wealth, say, okay, give them some of the money. They're not going to do it. You have to fight and get it. So the epistemic test is the critical thing that real numbers and so on, which are supposedly essential, were invented just because the West did not understand the calculus, but they are of no value and no practical, no epistemic value. Decolonized courses exist in calculus, in statistics, in Raju Ganit. Now it depends on the will of the colonized to decolonize. Now I'll add just one more epilogue. Very critical issue. People take great pride that Indians invented calculus. And it is point to it because the church false history was all about proving superiority, and racists and colonizers made full use of it. It's not just Macaulay. So the rhetoric of pride seems a good antidote to that sense of superiority or sense of inferiority that they tried to instill into the colonized. But I see it as a matter of great shame. Why? Because 75 years after independence, we keep growing Kerala school and keep studying Thomas calculus for IIT. So I think Aparna here was in IIT, you studied from Thomas calculus for IIT in order to create it, to clear IIT. Everybody does that, they're still doing it. And later, if you study, you might study real analysis. But the point is, you're talking of why are you not willing to change? Because what? Actions show what you really believe. So therefore, it's a matter of great shame that we don't really understand how that Kerala calculus is not critical to the teaching of the calculus, just that infinite series are easy to recognize. And the point is that the source of false history is not Macaulay. The same thing happened all over the world. It's not just about India. Macaulay came only to India. But colonial education is the same. Calculus is taught the same way in Africa. It's taught the same way in South America. Everywhere it is taught the same. And it is insufficient to understand just one church trick. Church has hundreds of tricks. Okay, so for example, one campaign which is very active in the US is the caste system. Indian society was iniquitous. But caste system also existed in Africa. And Africans had no problems with it. Sheikh Anta Diop will say that in pre-colonial Black Africa, it's just a division of labor. So was it iniquity? Therefore, also Aryabhat is important because Aryabhat it's Aryabhat, by the way, not Bhatta. And that changes the caste. Bhatta is Dalit, lower caste. Bhatta is Brahmin. And people confuse the two. I have this article in Jansatta, maybe you can take a look. It's taking a long time to load. Quick. At least that should not. So this is an article in Hindi, unfortunately. There's also an article in English. I'll just show it to you. So the wrong spelling breaks the story of ancient Indian integration across regions and castes. Because Aryabhat was a Dalit from Patna and his disciples Nilkant, who writes Aryabhatiya Bhashya, the highest caste Nambudiri Brahmin from Kerala. He has no problem being a disciple of a Dalit. I think that's a very important story to tell. It's never told. That's also why I don't want to keep saying. So there's an article, Aryabhat Dalit, his philosophy of Ganit. It is available this. So this is not just one, and this is just one example. There are hundreds of ways of fooling people. So you have to be alert to the possibility that you have been fooled all the time. And the real origin of axiomatic reasoning is the church, not Euclid. And if you keep doing wrong math and keep relying on experts who are not publicly accountable, it's a problem. No debate has been possible. I am worried because I don't know how long I am going to survive, maybe another 1-2 years, and then no debate will be possible. I even asked the Union Education Minister, let's have a debate. All right, it is just one instance. I asked many people, but Union Education Minister was one of them. And he said it's not possible. If it was left to me, I would do it in 1 minute, but it's not possible. So this was reported there. I'm just giving an example that it is not possible for people to do a public debate just like, it's a society during Inquisition. Could you have a debate on a heretical notion? You can't even debate, right? That's such a terrible thing. And I think this is a collective failure of the colonized society. It's not just about netas and babus and experts. Also, ordinary people are not able to even organize a debate. And what about the successful people in industry? Take Sundar Pichai. He also went through IIT. He also did Thomas Calculus. He doesn't want to invest anything to change it. I mean, don't do it for moral reasons. Do it at least for Google's better profit. Because we need it for better trained manpower. So if they don't, well, it will result in poetic justice. They will fall behind in the technology race. And anyway, decolonization is possible only if you desire to be free. Okay, we can't just keep crowing about Kerala calculus and so on. It's amazing that they fear to rectify or discuss the much bigger problem of math teaching. And I want to add, I have nothing against Kerala. My mother was from there. Thank you very much.
Excellent, excellent. So first of all, thank you so much, Professor Raju. I know for myself, I can listen to you for hours on. So I know you had to rush a bit today, but I'm hoping you'll come back and share more with us at a future time. And I promise we will not thrust the host responsibilities on you in the future round of this. There are many comments here, and generally speaking, all the themes that you've shared are very informative, but also quite depressing. And I'm going to pick up a comment on the chat from, generally the depressing for parents is how do we help our kids get a better sense than we were given. So essentially picking up on colonialism being a state of mind, and given this reality, it's disappointing experience how your experience of dealing with Indian education authorities, but how can we catalyze change as common people? So parents at home, how do we help our kids have an alternate view and a better understanding of contributions?
Yeah, that's a good question. But as you said, I've been struggling with it for so long. So all the material is ready. Question is how to initiate the change. The point is, if you look at the politicians, they are mighty scared, at least in India. And in South Africa, for example, there was at least a debate. Now, there hasn't been a public debate in India. Nobody is able to do it. See, if you'd ask me, what do you tell ordinary people? I said, you have to make experts publicly accountable. So you bring them out in the open that you are teaching this nonsense in college. Please come and defend real numbers. They are not willing to do it. Now, if you swallow that, then there is no escape. Then you are a slave. I mean, there is nothing to be done. So there, to resist, to break slavery of this kind, mental slavery, you have to fight. It's not just going to come. Nobody is going to hand it to you. Nobody is going to hand over freedom to you on a platter. You have to fight for it. If people are not willing to fight, if they say, oh, this is mathematics, we don't know 1 + 1 = 2, let's keep quiet, we don't know what is happening, then you are keeping quiet for too long. Because it's not that you can have an infinite amount. Maybe you have an infinite amount of time. I don't. So, I am concerned. And I think that you have to fight. You have to force people. You have to go to your schools. You have to go to your colleges and say, look, if you are teaching this, please defend it publicly. Somebody is saying this is complete nonsense. Demolish it. Are they willing to do that? Why are they not willing to do that? And there is the catch that they are not willing to do that because they know they don't have a ground to stand on. Otherwise, why should they not come for public debate? And what is so big? You're teaching something, somebody is teaching something in St. Stephen's. I say, come on, you're teaching real numbers. Let's have a debate. You spend a few hours to debate this. They're not willing to do it. Or somebody is sitting there in Tata Institute. I say, come on, debate it. Or our Jayant Nalikar is sitting, who writes in NCRT textbooks. You have written this in the textbook. Can you defend what you have written? They won't respond even. Because that's the only way they can defend. The moment they despond, they're finished. And they know it. So you have to fight. No way, unless you force them to do it, unless you say somebody is appointed an expert, come out, discuss it in public. We don't want your distance behind closed doors. So you have to force the expert. Why can't the government force them? There's so many government employees as mathematicians. Why can't NCERT force them? It's easy to do it. If somebody wants to do it, and public has to build up pressure because the politician is not interested. He says, where's the money in it for me? There's no money for it.
Yeah, so fighting at our respective domains is obviously a thing to be taken up. At our home environments, what are the mechanisms parents can influence and guide their kids to broaden? Of course, as some of the parents have noted, they have to pass the exams. They have to pursue whatever the mainstream forces us to pursue for achieving the exams and career objectives. But while the fight is on, what are the resources parents can access to broaden and appreciate the more real and merited context?
You see, it is a huge amount of propaganda. First thing you have to tell them is not to believe in Wikipedia. And you have to tell them to check, trust. That's what I did with my kids. I took everything from their textbook. At that time, a whole lot of changes had been made this way and that way. And then I said, look, this is the original, and see what they are talking. So that builds up resistance to this kind of false history. You need to do that. Need to tell them that everything, just one lesson, check, cross-check. Don't believe anything, especially don't believe if it is coming from some authoritative source. Check it. And the moment you find you can't check it, then you know that the whole thing just crumbles. And that's the first step. Start with history and then go on to mathematics. So history is easy. And it is full of stories, so children can look at it, understand it, then go to mathematics.
In general, then, the theme being stole, and the original Jesuits stole the knowledge. And my question to that is, if they stole consciously or they did not give credit initially, and in today's paradigm, if the credit is not being given, is it conscious or is it ignorance?
Very conscious,
what is
very deliberate, just as they did. They stole knowledge from Arabs. They attributed it to Greeks. So this is a very, I'm saying false history is a very deliberate church strategy, age-old church strategy. So when they got it, they said the first Christian who finds it, he must get the credit. So it was very deliberately done in that. We think that it is very fanatical, but they were fanatical times. Completely fanatical at that point of time. Now they are much more secure, they can tolerate some criticism and so on. But they are completely fanatical. I mean, think of all the genocide that took place, think of the slavery that took place, it's all the result of fanaticism. So it was very deliberately done that false history is a weapon of power, that it can deceive people, that you can talk of your superiority based on false history. So that is my point, very deliberate. Newton knew. Why is he calling Leibniz the second discoverer? He doesn't claim credit for calculus. He knows that it has been floating around from the time of Cavalieri, from the time of Kepler. He knows that. So any good scholar knew that. But he was also a fanatical Christian himself. No, he says, when he talks about the chronology of ancient kingdoms amended and so on, he believes in the creation story in the Bible. He says, what are the ages they are giving before the creation of the world. So, we have to really understand that it was really a valiant thing. And you have to also understand that to get it back, you can't just do, somebody is asking a question whether you can socialize and make people enthusiastic. It's not a matter of enthusiasm. If you want to fight, you will get it. If you don't fight, you won't get it. Finished. It's as simple as that. It's not that you get people and you get them to somehow we won't fight the system, we'll make people enthusiastic. It's not going to work. Can you imagine fighting slavery like that? It won't happen. right? It has to be, there has to be a proper struggle. You can't even have a debate. So we will go to our people who won't fight, we will talk to them. That's not going to work. It's a strategy which is doomed to failure. You have to contest. You have to force people to contest what they are talking about. If they can't defend, then how is it knowledge? They can't defend what they are teaching in the classroom. Public lectures, how are they teaching the students? Call out the teachers. There has to be, that is the only solution that I see. It is not that I will make people enthusiastic, I will give it to them. Take it, do it. I'm not part of it. Do it by all means. I think unless you contest, it's a waste of time.
Right.
So you need an alternative syllabus that is constructed. You need an alternative philosophy that's constructed. All right, everything is there. Now, if you just want to make people enthusiastic and you don't want to contest the system, then stay a slave all life. Then don't dream of this. Right? I think it's very straightforward. And can you imagine somebody in the deep south in America during the days of slavery saying, oh, let's make our slaves enthusiastic and they will be released? It's not going to happen. I mean, it is what kind of, it's a pipe dream.
Sure.
Contest has to be there, and the contest was there because of the Civil War. Because the Civil War, they were released and the segregation continued. Again, there was a contest and then only it stopped. So unless you contest it, it's not going to be stopped. Because they are doing it deliberately, they know they can pressurize you. They know you are not able to speak a word of mathematics, and they will pressurize you to the maximum extent possible. So unless you contest it, unless you say, come out, let's talk about it publicly, let us see what we actually know, let us see whether you are teaching nonsense in class, whether you're taking sense in class, then they will respond. You have to force them, otherwise they won't come.
So do you also feel like this very axiomatic approach to math, and which of course spills over other disciplines such as economics and the normative theories of economics based on axioms, does it alienate kids from becoming actually interested in science and math studies?
You see, there is a issue, much deeper issue. Let's take something in economics like Arrow's impossibility theorem. All right, where he is talking about, say, interpersonal comparisons of utility is laying down some axioms. The point of the axiomatic approach is that you can prove exactly what you want. And then you say this is all done in mathematics and people believe you.
Right.
You do that in physics. So the cosmos was created at some point in the past, exactly as we said it was. Stephen Hawking says that, and then you have a situation. So I think that you have to understand this idea that axiomatic allows you to distort the truth. I select an axiom. Who selects the axioms? West selects the axiom. You know any axiom that is being taught which was made by some non-Westerner? You might have some, you know, at some point of time, you might have what I would call ethnic, tokenism. So you take somebody who has a brown face or something and then put him in front. But that is just tokenism. So nobody actually has formulated all the axioms of set theory, von Neumann, Bernays, Gödel. They all come from the West. Why should you follow them? Why should everybody be forced to follow them? I don't want to do that. I don't believe in it. Because there are certain conclusions that you have to follow. Those conclusions follow from there. And then once you have control of the axioms, you have control over the conclusions. Like Aquinas, he makes an axiom about angels, and so you get a conclusion about angels. There is a statement about perfect market. Yes, it's not a serious thing about perfect markets. I might have talked about it, so I agree. But the whole point is not that axioms are meant to be true. They are meant to influence your behavior. It's not important whether you try to frighten a child by talking about ghosts. The question is not whether the ghost is true. The question is whether the child goes to sleep as a result. The ghost will come and get you. So,
right. So when you recognize these broad implications that actually spill over across all other disciplines, whether it's engineering, all the flavors of applied sciences, or social sciences that are increasingly becoming more and more mathematical,
absolutely,
you realize how damaging it can be for somebody's educational journey, as well as how we make use of science and engineering, broadly speaking, in the world. So I'm going to wrap up with that. Thank you so much once again, Professor Raju. This has been, as expected, an amazing lecture, and I hope you will visit us again sometime and give us more of your knowledge and experience, benefit of your knowledge and experience. Thank you. Thank you all for attending. I hope you benefited from the knowledge Professor Raju shared, and I hope you will connect with us at a future event. Thank you.